This is the third video about solving equations, manipulating equations. I'm going to do another one at least tomorrow, or whenever tomorrow really happens, where we go through some harder ones with numbers, ones like these ones here. Nothing different from what we did before, but of course there's more steps, so good to see some examples. But I am going to go through here equations with multiple variables, solving formulas when you don't know any of the numbers. It's the same. It's the same, it's the same, it's the same. The only thing is you don't know what the numbers are yet, but all of the letters represent numbers. So they follow the same rules as numbers. So one thing you need to look out for is it says solve for. So solve for A, solve for B, solve for X. So that's what we need to watch for. If it says solve E equals mgh for G, then G is the variable that I need to watch out for. That's the one I want. Everything that's not G, I want to get rid of. So let's do that. Is my variable alone? No. Why not? It's being multiplied by m and h. How do I get rid of m and h? Well, I divide by m and I divide by h. Why do I do that? So that I can cancel h by h and m by m. That's beautiful, right? Now I've got g all by itself on one side of the equal sign. And the only thing I need to do is remember to follow that rule, where I need to also divide by m and by h on the left side. So E over mh is equal to g. This is solved. Solved for g. Let's do some more. Solve A is equal to v over t, so acceleration, velocity, time. For v, v is the variable that I care about now. That's the one. So I ask myself, is it alone on one side of the equal sign? It is not. What's happening to it? It's being divided by t. How do I fix that? Multiply by t. Why do I do that? So that I have a top and bottom pair to cancel. That's really good news. I like to do that because now I just have v on the right-hand side. But I need to remember to do the same thing on the left side. So I multiplied the right side by t, multiply the left side by t. I'm going to write them this way because I like alphabetically organizing things. AT is v. But if you say t times a is v, it's the same thing. A times t is equal to v. That's all it takes. Same rules as if there were numbers, only there's no numbers. No big deal. Here, solve vf squared is equal to vi squared plus 2ad for d. Okay, let's find d. This looks maybe a bit more frightening than the last example. It's got exponents in it, it's got subscripts in it, but it's not. It's fine. We can do it. Get out of there. So I want to solve for d. D is my variable of choice. I want it to be alone. Just like with any simpler one, any term that doesn't have my variable that I am looking for, I want to get rid of. I want to move it over there. The way I can do that is I can say subtract vi squared from both sides, or I can just move it over and flip the sign. It doesn't matter. So I've got vf squared and minus vi squared. They're not the same thing. They both have v's, but they got a different letter underneath, so we're going to treat them different. And on the right side, vi squared minus vi squared canceled out. I've been using red for that before. I guess I should keep doing that. And what's left over is just the 2ad. I'm still looking for d. I'm not done. All I've done is I've moved that term out of the way, over to the left, away from my precious variable over here. Now, what's happening to d? It's being multiplied by 2 and by a. Okay, I know what to do about that. I divide by 2 and by a so that I can get rid of them. As long as I remember to do the same thing, divide by 2 and divide by a, to the whole left side. Not just to one of these terms or the other one, but to both. Everything on the left side's got to get divided by 2a because everything on the right side got divided by 2a. So then I have my vf squared minus vi squared over 2a is equal to the only thing left on the right, d. Looked complicated, not so hard. Last one for right now, solve d is equal to vt plus 1/2 at squared for a. I want that variable right there. So I'm going to do the same thing I did before. Everything that's not in that term that has the variable, I'm going to ship away. Oops. Didn't want to get rid of that letter. So I'm going to subtract this term from both sides. On the left, d minus vt is just d minus vt. On the right, vt minus vt cancels out. And I've left with the 1/2 at squared. I still want that a. Still not alone. What's happening to it? It's being multiplied by t squared. Okay, divide by t squared. Easy. Divide by t squared over here. Cancel that, cancel that. It's being multiplied by 1/2. I could say divided by 2. It would be true. But I could also just turn my brain off a little bit and say, okay, multiplied by that thing, that fraction. So I'll divide by that fraction. Cancel it out. And I've got to do the same thing on the left. And this is technically a correct answer here. This would get you full marks in this course. D minus vt is equal to 1/2 t squared, or over 1/2 t squared is equal to a. But dividing by 1/2 is really multiplying by 2. So, to be nicer, I would move that divide by 1/2 into a multiply by 2. And I would say 2 times d minus vt over t squared is equal to a. That'd be a little bit nicer. But this one is just fine. I'll do some more of these, of course, in class. But I just wanted to make sure to make a video like this tonight so that you could see it's not necessarily a scary thing. You just do the same rules. There's no numbers, or there's only a few numbers. It works just the same and it works just as well.